Welcome back to Aurora Tech Channel. Today, I will be reviewing the AtomStack A30 Pro laser engraver. Besides the engraver, I will also test out their steel enclosure, new cutting panel, rotary rollers, and the camera kit. This is a full package with everything you would ever need for a laser setup. Let's take a look at the features of the machine. The 400 by 400 millimeter working area is pretty standard for a desktop engraver. The laser module contains 6 6-watt modules with a combined power of approximately 33 watts. It has a thumb screw at the front to adjust the height to set the focal length, and it also comes with a removable protective cover. The structure of the frame is made of 4 aluminum extrusions. Instead of the 20 by 20 extrusions you see on other machines, it uses 20 by 40 extrusions with a thicker wall to provide a more rigid frame. It comes with an air pump and air assist nozzle. The electronic enclosure is located at the front, and inside is the laser controller motherboard with a touch screen that also works as an offline controller for you to save jobs on the SD card and run it without connecting to the computer. The overall look and design is in line with other AtomStack machines. I would like to thank AtomStack for sending me this machine and all their latest accessories, and with that, let's get started. First, I will set up the enclosure. The whole enclosure is made of sheet metal, and all parts are clearly labeled. There are quite a lot of parts, but the instructions are clear and there isn't much you can go wrong with. It took me over an hour to assemble everything because this enclosure is quite large for me. The lid is supported by 2 springs, making it safe and secure. This enclosure is built like a tank, and I really like it. Next, I will put the machine together. Similar to other AtomStack machines, we have 4 aluminum extrusions to form the frame. There's also the gantry, a 33-watt laser module, an air assist pump, motherboard and touchscreen, a power supply, some tools, some cables, and a user manual. The machine fits perfectly within the enclosure. Instead of using a regular honeycomb bed, I will test their F3 matrix cutting panel, which has smaller contact points with the workpiece, and it looks pretty cool. Let's test the air assist pump. The air is coming out of the nozzle, and the exhaust fan at the back of the machine is also working. It's quite strong but not loud, and the air pump is much louder. The machine included a steel gauge to set the focal length, so you can just use the thumb screw at the front to adjust the height of the laser module. Let's start with a sample file from the micro SD card. The motherboard supports offline control, and the touchscreen also works as a controller. I'll select the butterfly sample file, jog the machine to the starting position, save the position, and draw a preview frame. It looks good, so we can start the job. This 33-watt module is really powerful. I forgot to turn off the air pump, and as I don't want to use air assist for just engraving, I will turn it off and run the same G-code file again. This time it looks better. The ashes aren't being blown away, and the result looks cleaner. But since the G-code file is just a standard test file, it doesn't seem like it's best suited to this 33-watt module. So I will connect the machine to my PC using a USB cable and set it up in Lightburn. Just let Lightburn find the machine, give it a name, follow all default settings, and that's all you need to do. I will start with a 10,000 milliliter per minute test with different power levels for engraving, grayscale, and dithering image scanning. I'll draw a preview frame, and the position looks good, so I'll start the job. As a 33-watt module, 10,000 millimeters per minute burns too dark, so I guess it can do at least 15K or 20K millimeters per minute. Let's use the material test function in Lightburn to generate a test using a 5,000 to 20,000 millimeters per minute speed with different power levels. The result looks good, and it's still usable when engraving at 20,000 millimeters per minute, as 50% power and above still looks clear. There's actually no big difference between 15K and 20K, as the acceleration of the machine is set to 1,000 millimeters per second squared, so engraving something like these tiny squares won't let the machine accelerate much at all. Then I will do some photo engraving. I will use 20,000 millimeters per minute speed and a 100% power and dither mode to engrave this kitten. The result looks okay. It took around 27 minutes, which is not bad. Since the manufacturer suggests a completely different speed, power, and image mode, I will try to use the suggested 6,000 millimeters per minute speed, 20% power, and threshold mode and see which one works better. The job time is 24 minutes, which is slightly faster than the first one, despite engraving at a slower speed. Up next, I will do some cutting tests, starting with the same 3mm plywood. I will use the Lightburn material test to generate a test for 200 millimeters per minute to 2,500 millimeters per minute speed, and see what the maximum speed it can cut through this 3mm plywood is. The fastest speed it can cut through is 1,000 millimeters per minute at 100% power. For 600 millimeters per minute or slower, it can cut through with any power starting from 60%. Let's engrave an eagle and cut it out. The cut is clean, and the engraving using 20,000 millimeters per minute and 30% power is doing okay on this plywood, but as I forgot to turn off the air assist pump again, the engraving result could be better. Then, let's try some thick wood cutting. I will start with this 1/2-inch poplar wood, which is around 12.7 millimeters. I will start with no air assist using 100% power with speeds at 200 millimeters per minute, 150 millimeters per minute, and finally 100 millimeters per minute. After that, I will turn on the air pump and use the same speed and power. It It looks like the air assist improves cutting by a lot as the edges are much cleaner. However, I can only completely cut through this half-inch poplar wood using 100 milliliters per minute no matter with or without air assist. Cutting at 150 and 200 milliliters per minute was unsuccessful. Next, I would try this common wood board from Home Depot. The thickness is 19 millimeters. First, I tried 100 milliliters per minute, but it didn't cut through, so I then slowed it down to 75 milliliters per minute. It looks like the wood is cut through completely, but a diode laser moving too slowly will increase the risk of catching fire. And as you can see, the bottom has a flame for a few seconds before the laser head moves away. The 75 milliliters per minute speed with 100% power cut almost cut through completely, with just a tiny bit of wood requiring a little snap to break it off. The bottom is a little burnt, as this is the area where the flame was at the bottom. It kind of works, but the result of using a single pass to cut this thickness isn't that impressive. The manufacturer also suggested using multiple passes, so I will use a 750 milliliters per minute speed at 70% power with 9 passes. The result looks much better. It didn't catch fire and it's much cleaner. After that, I will engrave on this coated metal card. Aligning this small black card is quite challenging, and I didn't align it well on my first try. As these cards are thin, 2 cards can stick together. I didn't realize this had happened until I started the job with a 1000 milliliters per minute speed and a 50% power. The power was too high and the card on top warped. But I still let it finish to see how it would look. The result isn't bad, it's just that my alignment was off by a little too much. I will try it again and remove the protective cover. After a few adjustments by moving the card around, it looks good to me. So let's start the job. This time, I'm using a 3000 milliliters per minute speed and 25% power. I wouldn't say it's perfect, but it's much better than the first one. Up next, I will try to engrave on this slate coaster. Aligning this round workpiece can also be challenging, but I'll make the pattern larger than the slate so it can just engrave from edge to edge. I will use a 6000 milliliters per minute speed with 60% power. The result is perfect. The pattern indeed engraves from edge to edge, and I have no complaints about this coaster. Then, I will try the Rotary roller. The R1 Pro roller kit actually comes with 2 rollers, the traditional one for mugs or bottles, and a chuck type for other objects. The good thing about using this enclosure is you don't need to add risers or wood blocks to raise the machine. The bottom of the enclosure can be opened, and the cutout fits both rollers perfectly. I will engrave some honeycomb patterns on this oak wood cylinder. It looks pretty good at first, but when it rotates to the clamp, I didn't leave enough clearance so the air assist nozzle of the laser head actually bumps into the clamp. This creates some unexpected movement and affects the patterns. Every time it comes to the part with the clamp, the patterns look bad, which you can see here and here. So I adjusted the position to leave enough clearance and started the job again. This time, the result looks much better, and I didn't see any messed up patterns like those on the first one. Finally, I would also like to test out the camera. This kit comes with a clamp, an arm, and the camera. It requires you to clamp at the back of the machine and raise the camera to be about 450 millimeters away from the bottom surface. But as I'm using the enclosure, I can't use the clamp and arm. At first, I tried to mount it at the top of the enclosure, but the distance was too great at 730 millimeters and didn't work well. Then I measured 450 millimeters, which is just around this position. I designed a mount to fix the camera to, but when the camera is not in use and I want to close the enclosure, there isn't enough space in the enclosure and the camera bumps into the laser head. So I redesigned the mount to make it detachable. I used the slot to align its vertical position with the green acrylic cover on the enclosure. Additionally, I superglued 3 magnets on both the mount and the enclosure to align its horizontal position. This ensures that every time I attach the camera to the enclosure, it will snap into the exact same position. It's crucial to keep the camera at the same position as where you perform the initial camera alignment in Lightburn, as well as every time you use the camera after that. This is the actual view from the camera. As the enclosure lid is supported by 2 springs, it will also move to the same position every time, and this angle is just good enough to cover the entire cutting panel. Let's see if this works in Lightburn. I will run the standard Lightburn camera alignment wizard, which requires you to move the alignment card around and take some pictures. After that, it will engrave some alignment points at 4 corners, which I will just use a large piece of cardboard for. Then, you need to click on the center of the target to let the software do image correction. After the alignment is done, we can just take a snapshot of the workpiece. I will use the black metal card and try to place the Batman logo at the center. Compared to using the preview frame, it's much easier. I will just align it on the screen and start the job. It's pretty accurate, and it's basically aligned at the center of the card without much effort. When I'm not using the camera or want to have the machine fully enclosed, I can simply detach the camera along with the magnets. Okay, let's talk about the pros and cons of this setup, starting with the pros. 1. For the hardware, the machine itself is well made. The frame is rigid, and the included air pump is 2 times larger than the one used on other machines, but the airflow is also much stronger. The 33-watt laser module is also powerful. It can almost cut through a common 19mm wood board in a single pass depending on what type of wood it cuts. For solid wood like poplar wood, it should be able to cut even thicker. 2. I love the enclosure. It fits perfectly with AtomStack machines, the adjustable legs let you raise the machine for accessories like the rollers, and the lid is supported by 2 springs. This not only makes it safer, but also allows it to open to the maximum at the same position every single time, which lets you attach a camera without using a dedicated mount. 3. The new cutting panel works better than regular honeycomb beds. As the contact surface is smaller, it leaves almost no marks on the bottom of the workpiece. 4. The Rotary roller kit comes with 2 rollers, allowing you to work with standard mugs and bottles. The chuck-style one can grip other cylinder or ball-shaped objects that will be challenging for the traditional roller. 5. The resolution of the camera is pretty good. It's a 5-megapixel camera, which is slightly higher than 2K, which is more than enough to work well with the laser engraver. The sensor also works well in darker environments. If you don't use an enclosure, you can use the mount to fix it at the back of the machine, which should fit most machines in the market. Now for the cons of this setup. 1. The machine just uses a standard laser controller motherboard and a touchscreen that you often see in other lower-priced machines. The touchscreen is functional, but it requires at least 1 G-code file in the SD card to operate the machine, which is not the best. When drawing the preview frame, it also requires some time to load depending on the size of your G-code file. This is a common issue for all machines that use the same motherboard and screen. As AtomStack is a more reputable brand compared to other brands that sell lower-end machines in the market, it would be better to have their own UI and motherboard with some improvements rather than a generic off-the-shelf combination. 2. The air pump is not powered by the motherboard, and it uses a splitter cable from the power supply of the machine, so you still need to turn it on and off manually. As you saw in my tests, I occasionally forgot to turn off the air pump while engraving, which would make things worse. If it's powered by the motherboard, we can control it using G-code, so it will automatically turn on when cutting and turn off when engraving. Other machines like the Creality Falcon 2 have this feature, which can help avoid manual errors and offer more consistent results. 3. The enclosure itself is super nice and is the best enclosure I've ever used. The AC1 camera is also pretty good, but the problem is you just can't put two AtomStack products together without doing some mods. Of course, you can design a detachable mount for the camera to use with the enclosure, but it would be better for AtomStack to release another camera with a slightly wider angle lens that can fit inside the enclosure, similar to the Xtool M1 diode laser or their P2 CO2 laser, which would be a more complete solution for users who want the enclosure with the camera. In conclusion, this setup is solid, handy, and a near-perfect full package for laser engraving. The powerful laser module, strong air pump, better cutting panel, and all-metal enclosure make it an excellent choice for home users or even for use in a shop. While it would be better if the camera could work with the enclosure right out of the box, the detachable magnet mount still allows for a functional setup. I'd suggest that AtomStack consider creating a bundle that includes all the items. If you are interested in the AtomStack A30 Pro and its accessories, I've included the links in the description. That's all I wanted to share about this machine. If you found this video helpful, please consider giving it a like and subscribing to our channel. Thank you for watching, and I will see you next time.